So taking a look at this, we are working our way through Unit 5. We're already halfway done with Unit 5. That's how quick Unit 5 is. It's like a little mini lesson. So we did graphing, substitution, elimination, and had that. Then this next check for what's that? No, those were 3 separate ones, yeah. So then this is going to be our next check for understanding 4 and 5, and then this. So we're going to graph linear inequalities today, systems of inequalities on Monday, and then we're going to spend a good amount of time on those word problems. And then that's it for Unit 5. So let's start learning Target 4 right now. So you don't have a piece of graph paper in front of you because I'm just going to do a quick little recap here. So I want you to take a look at, and if you remember, y equals, let's say, 3x plus 5. Okay, so you're just kind of watching this for a minute. So y equals 3x plus 5 is not an inequality. It has an equal sign. It has an equation. I'm just going to kind of show you this here. So a little review of this would be 1, 2, 3, 4, 5, because B is where you begin, M is where you move, right? Up 3 over 1, okay? And then all the other times we did this, you just took your ruler and then you graphed your line, right? Okay, so this is y equals 3x plus 5. Big deal, right? So what I kind of wanted to make sure you knew is that if I were to say to you, well, first of all of these points that are on this line, wherever they're at, whether they're at a perfect little meeting point or not, they're all solutions of this equation, right? So if I were to say, is the point -2, 3 on the line? The question would be, is -2, 3 a solution? That's what you're going to see. They're going to say, is -2, 3 a solution? And you're going to say, I don't know. What do you mean, is it a solution? It's a solution if you take the x and put it in for the x, and you take the y and put it in for the y, and if you get a true statement, it's a solution. I can tell by looking at the graph that it's not going to be right? So if I'm looking at this graph, -2, +3, it's not on the line. You can see that. So I'm going to prove to you, if you don't have a graph, how you can still tell whether it is or isn't on the line. So what we're going to do is take that 3 is the y, and then the x is -2, and 3, does that equal this? Does 3 equal -1? No, it does not. And I know that it wasn't going to work out because I can see that. So the first thing I need you to understand is that if I give you a point and I give you the equation and say, okay, is this point a solution? You need to say, I don't know, but let me plug them in and tell you. So plug in the x for the x, y for the y. True is yes, false it's not. Easy enough? Okay. So now what we're going to talk about is the fact that we're not talking about equations anymore. We're talking about inequalities. And an inequality means I'm going to take that y equals and replace it with either this or this or this or this, right? It's going to be one of those 4. So let's say, for example, if I were to say y is less than 3x plus 5, it changes everything. So before, I wanted my solution to be y equal to 3x plus 5, meaning it had to be on that line. But now you're telling me I want you to take that same line and accept it, instead of it being equal to that line, it has to be less than that line. So what that means is this. Here's the good part. You still start the same way. Plus 5. Up 3 over 1. That's where you stop, though. That's the only 2 things that are the same. Because what you did in the past was you took your ruler without even thinking and you drew a big old line, right? So I want you to think about this. So what you're telling me is that by changing this equal sign to a less than sign, it can't be equal to that line anymore. So I can't really draw a line. So to get you kind of thinking about that, I'm going to ask you to remember what you did when we had this problem. Where on this number line are the numbers greater than 6? To the right. But I started out by putting this here. But it couldn't be 6. But I still had to start at 6. So how did I show that it couldn't be 6? Somebody said start at 7. Why? Why can't I start at 7? JC.
Because you're forgetting all the numbers in between.
Yes, all those beautiful rational numbers in between. I'm forgetting about those. So I have to start at 6. I know the greater is to the right. But the way that I showed that it couldn't be 6 is that I just didn't color it in. Right? Do you remember that? So if I said y is greater than or equal to 6, do you remember me coloring it in? So what I'm about to show you is very similar to the don't color it in versus color it in. Open circle versus closed circle. So I want you to actually see, if you were a mathematician and you had to create some crazy rules for 8th graders to know, how could you show that you need it to be a line, because you're going to need to show less than, but it can't really be a line? What kind of creative ways? Yeah. Yes. Could you kind of make a line but make it a dotted line instead of a solid line? Okay. So what I'm going to do is say, okay, I need there to be something there, but I also need the kids to know that the solution can't be on the line. It needs to be less than it. So then now we have something called a dotted line or a dashed line. Okay? So that's part 1. So now that means, okay, I need it to be less than. So the first part is figuring out whether the line you draw is solid or dotted. So then now where do you think? This is part 2. If you had to do some shading, if I gave you a crayon and said, you essentially what you did was created 2 separate parts of a graph, right? Whenever you draw one line, you've created one part, 2 parts. Where on this graph, which one do you think the area is going to be less than this line? It's not what you think. Just be careful. Less than usually means to the left, right? But do you notice, even though this line is steep, what direction am I going? Up versus down. And up on a graph means greater than, doesn't it? And down on a graph means less than. Oh, I just said it. So above goes up, less than is below, which goes down. So which half do you think I'm going to shade that is less than 3x plus 5? Above or below? Less than is below. So you are going to, and I'm going to, okay. So you are going to, actually, when you get your paper, shade this whole area. And I didn't extend that. So that is my answer. A dotted line with a bunch of shading on it. Yep. Okay, we got to talk about this a little bit, though, because I want to prove to you what this means. Remember before how I picked a point that wasn't on the line and I plugged it in and it wasn't true? Well, it wasn't true because it wasn't a solution. Let's pick a point that I know is a solution. Let's pick a point in quadrant 3. That's obviously in the shaded region, right? So the name of this point is positive 3, negative 2. I can very obviously see that it's a solution of it. So I'm going to prove to you mathematically that it's a solution. So I'm going to take that in for the x and that in for the y. So is negative 2 less than 3x, or 3 times the x, which is 3, plus 5. Is negative 2 less than 9 plus 5? Is negative 2 less than 14? Yeah, that's true, right? That is a true statement, which I expected because I told you, and you saw with your own eyes, that 3 negative 2 is a solution. Do you think that point would be a solution if I plugged it in? Yes. Do you think this point would be a solution if I plugged it in? Do you think this point would work? No. Now here's the trick of the day. If I plug this point in, do you think it would work in this equation? Ooh, it's on the line. So let's see. The name of this point is 0, 5, right? Because it's the intercept. So let's put 0 in for x and y in for 5. So let's say 5 is less than, you're going to see it real quick, 3 times 0 plus 5, that's 0, is 5 less than 5? No. 5 is 5, right? 5 equals 5. So I didn't expect that to be a solution because the line is dotted, right? Watch what could happen though. If I were to change the problem completely and do what? Put a line under there. What does that mean? That means that, okay, now I want to see all the solutions that are not just less than the line, but, okay, it can be equal to the line. Do you see what I mean? How does that change what I should do here then? It should be a solid line instead of a dotted line now. Do you see this? Okay, so that's good, because now then when I did this, is everything okay? Is 5 less than or equal to 5? Yes. Okay, so let's get to this part of your notes. So that was kind of a little recap here. So remember that y equals mx plus b. B is the y-intercept. And that's also where you begin to graph your line. And some of you, I think you need a little review on this. M represents the slope. Does everybody remember what word I told you that why they call it M? It's a French word. And it is, you know how in Spanish you have your AR, ER, and IR verbs? This ER verb, monter, means to climb in Spanish. So, and what do you climb? Hills with slopes. So, I say it's M because that's where you move once you begin at the B, right? So now you're going to see all these kinds of inequalities. No more equal signs. So there are a couple more rules though. So, you are going to use either a dotted or a solid. And I want you to think about what we just did and tell me, of these 4 symbols, which 2 will I use a dotted one for? If it's just less than or, yes, less than or greater than. Because here's my hint to you. If it's got a solid line underneath it, then the line is solid, right? So which 2 will I do a full solid line for? Yes. Okay. So now let's talk about the shading. There are going to be shading areas that are going to either get shaded above it or below it. This one, we're going to do some more problems on it so you can kind of see. So above means the numbers are getting greater. So we're going to shade above for a greater than or a greater than or equal to, correct? Which means then that our less than will be the below. Less than or equal to. So go ahead and take a look down here. The symbol that we're talking about is greater than. So will it be a dotted line? Yes. And the shading is greater than, so I want to go up, which is above, right? So less than or equal to means that point can be on the line. So I'm going to put a nice solid line to show that, kind of like that darkened in circle. And then it's going less than though. This is going to be the trickiest thing because you really have been thinking less than to the left, right? But if you're thinking to the left, it's actually going up. So you have to stop looking at it as left and right. You have to start looking at it as above and below. So this is going to actually be shaded below. And this is also solid, but this time it's greater than, so it's going to be above. Okay, so let's stop talking about it and see what it looks like on an actual graph. So go ahead and flip that over.
So I just want to say dashed.
Dashed or dotted. I should have used the same word. I don't know. I don't like the word dashed. I think, what makes more sense to you, dashed or dotted? Dotted line.
Like you're running away.
Yeah. Whatever you guys want to do. Okay. Yeah. All right, so let's do this. What's the y-intercept? 0, 1. What's the slope? 1. And what is this slope? This is a great review for some of you who are still a little shaky. What does that slope tell us to do? It tells us to go up 1 and right. Yes, we're going to say right because that people. So I have people going left. And that makes it negative then. All right. Okay, so let's do it. First, plot a point at the y-intercept, which is 1. So there we go. Step 1 done. Second, keep your pencil on the y-intercept. Use the slope to go up 1 and right 1. Okay? And right after you put that second point, that's when you stop. You stop because you're used to taking a ruler and going whoosh. And if you're lucky, it'll be one where it requires that. But you know how many times I've seen this? There'll be kids that will just go boom, and then they'll go, oh shoot, it's supposed to be dotted. And then the good thing they did it with the pencil, because I will see like pencil eraser marks like that, and it saved you, right? But in this particular case, because third, careful, connect the points. Should you use a solid or a dotted? In this one, it is a solid, so you're okay with that. It's the when it's supposed to be dashed, that. Okay? When I make my lines, you will see me take that line and extend it all the way out to the perimeter of my coordinate plane. Because I want you to very obviously see 2 areas. Okay? So I did a solid line. And now I have an area above the line and an area below the line. We already know that the solutions can be on the line, right? So what area should I shade if it's greater than? Greater than is above. Okay? So go ahead and shade that in. Get the color. Okay, does that make sense? Gary, your throat hurts, isn't it? I'm going to get some water. Okay. All right, let's do example 2. What is the y-intercept? So the y-intercept is 0. It's the origin, right? But our slope is negative 2/3. And that tells us to do what? Down. Good. 2 and right 3. So let's do what we're told. First, plot a point at the y-intercept, which is right at the origin. Second, keeping your pencil on the y-intercept, use the slope to go down 2 and right 3. Third, connect the points, but be careful. We have a less than. I need my solutions to be less than the line. They can't be on the line. So what kind of a line do I want? A dash. We'll use dash for those people who like to dash. I'm going to go all the way to the corners of the graph. I have created 2 parts to my graph. The shading is the last part. Should you shade above or below for less than? Did you do solid? Yeah. Eraser. So less than is below. Okay? Got it? Easy peasy. Okay, let's take a look at the purple sheet that you have. Let's do a couple more of these together. Because there are going to be a couple things that happen that I want you to kind of be aware of. We don't really need to do 1 and 2 because we just kind of did one just like that. I want to scooch down to 3, 4, but specifically 5. Actually, this would work too. So this gets me what? First thing I notice is that it's in standard form and not slope-intercept form. And if it's in standard form, could you graph with the intercepts? Sure. Could I do this and say, okay, my y-intercept is -6. My x-intercept is going to be not so pretty, but it would work, right? Okay. If you are just comfortable wanting to solve it for y, there's one little trick that I'm hoping you remember from Unit 2 or whatever it was. Negative 2y is greater than negative 5x plus 12. What am I about to do? Divide by a negative. And what kind of problem are we dealing with? An inequality. And for some of you, you just kind of ignored that rule and never switched it in the first place. I need you to do it now. If you multiply or divide by a negative, you must take that sign and flip it. Otherwise, your shading is going to be in the wrong spot. So this is actually less than 5 over 2 and then minus 6. So there's my minus 6, which I knew was there because it was one of the intercepts. And I'm going to go up 5 over 2. I'm going to put a solid line. I'm sorry, I said solid, but wrote dash. A dash line. And now I want to shade less than. Above is greater, below is less than. Here's how I can tell every year the people who forget to switch their sign when they divide by a negative. Because the shading is on this side instead of on this side, right? Because, or it's tricky. Guess what happens sometimes? This is where I'm like, oh gosh, how do I do this? They forget to switch the sign, but then they graph it in the wrong spot. So then it ends up looking right. Do you know what I mean? I don't know if you followed that or not, but. Okay, let's get down to 7 and 8. There's those pesky horizontal and vertical ones, right? Again, it is time for you to remember that the y's are horizontal and the x's are vertical. Even as early as the test yesterday, I had somebody graph the y equals wrong. Y equals are horizontal. At -4, it's going to be solid. And this is a no-brainer. There's an obvious above or below, right? So which area is below to the left? Or I'm sorry, less than is below. Okay? Number 8 is a little trickier, but I have faith that you guys can figure it out. So let's get to that x equals 7. So there's my x equals 7. So it's going to be a vertical line. It's going to be a dotted line. Except when you do this, there is no above or below. Yes. So now this is where common sense kicks in and you say to yourself, well, where on this number line, or on this coordinate plane rather, would the numbers be greater than 7? To the left of 7 or to the right of 7? To the right. Because there, see that number? 8, 9, 10. These x's are 6, 5s, and 4s. So the vertical ones are going to, and make sure you don't ever shade too close to the line that I can't tell whether it's dotted or solid. Okay? So are we good on this? So we understand the 2 extra parts of it. Solid or dotted? Okay. Because now I want you to turn that purple sheet over. And what do you see? Yes. Well, it's not a quiz, but yes. So here's the other thing. It's when can you kind of tell which side's shaded? Yes, they already did it for you. So what should you have to do? The inequality. So yes, we are going in reverse order. So I don't know if you can kind of tell which is shaded. So here's how we're going to go in reverse order. You're going to start. So you got them all shaded? You can kind of tell, but. So let's take a look at number 7. Normally, I go like this first. Woo, y equals. And then I put my slope and my y-intercept. It's not going to work this time. So identify your m and your b. Where do you begin? Where do you move? You begin at 2, and you moved where? Down 2 over 1. So then I'm even going to go up and say 2x minus 2. Oops, sorry. I have that backwards. So you're beginning at positive 2. You're moving down to negative 1. I did it backwards last hour. So this is going to be negative 2x plus 2. See, so what I did is I kind of left a little space there. And so now I need to figure out which symbol goes there. So the first thing I like to do is decide what direction and then decide whether I put the line under it or not. So I shaded below, or the shading was there below. So that is a less than. And then I go back and I look, is it dotted? Yeah, so I leave it. That's it. Okay? Let's take a look at number 8. So I am beginning at 1, and my slope is, 1/2. So I have my 1/2 x. A lot of you are forgetting that x, and I'm getting close. If you do it more than once, I start taking points off, but don't forget that x. Your y-intercept is 1. There's your y. Now we figure out which symbol. It's above, so it's greater than. And can the solution be on the line? Yes. Okay? So then be prepared for this tomorrow. Tomorrow I'm going to say to you, here is an inequality right there. Tell me which quadrants there are solutions in. Are there solutions in quadrant 1? Sure. Are there solutions in 2? Will there be solutions in 3? Will there be solutions in 4? No. Okay. Can there be solutions on the boundary line? Yes. Can there be solutions on the boundary line here? No. Okay. And then be prepared for me to say -6, 8. Is this a solution? And you have to be able to plug it in, right? Okay? Everybody got it?